So when we're talking about right triangle trigonometry, right now we have this triangle that is labeled, and this 90 degree, this box here is 90 degrees. This top corner that I have shaded in red, we're going to go ahead and call this theta. And this bottom piece over here right now, we're just going to go ahead and leave it blue. We're going to talk about that in a moment. Now, when you're looking at your major trig functions, there is one really popular way of helping us remember it, and it's pronounced Sohcahtoa. What that means is that the sine of any angle is equal to the opposite over the hypotenuse. The cosine of any angle is equal to the adjacent side over the hypotenuse. The tangent of any angle is equal to the opposite over the adjacent. So where that acronym comes into play is it's sine, Sohcahtoa. Now, do remember that these are not the only functions that we have. We also have the cosecant, the secant, and the cotangent. So let's just go ahead and put those in right now, and they just get flipped, right? So if I go ahead and come down, and the opposite of the reciprocal of the sine is the cosecant of theta, so that becomes the hypotenuse over the opposite. The reciprocal of the cosine is the secant, and that becomes the hypotenuse over the adjacent. And the last one, the reciprocal of the tangent, is the cotangent of theta, and that is just equal to the adjacent over the opposite. Now, the only part of this triangle that will always stay the same name is the part that is across from the right angle. So going directly across from the right angle is always your hypotenuse. So which side is the opposite side and which side is the adjacent? And that has everything to do with the angle that you're talking about. So if I want to first start with this red angle up here, theta, this piece right here that we're talking about. If I'm talking about this side right now, so directly next to it or adjacent to this red angle is this side, and that's what we call the adjacent side. Now, across from this angle is the opposite side. Now, if we go ahead and give this some values, you can go through and find the sine, cosine, and tangent. If this is a 3, 4, and 5 Pythagorean triple, where 3 and 4 are the legs of the triangle, if I want to find the sine of theta, the sine of theta is the opposite, or 4 over 5, the hypotenuse. Now, if I want to do the cosine of theta, then that cosine of theta is the adjacent over the hypotenuse, 3 over 5. The tangent of theta would be the opposite over the adjacent, so that would be the ratio of 4 over 3. And all of the reciprocal identities at the bottom, the cosecant, that would just equal 5 over 4. The secant would equal 3 over 5, and the cotangent would be 3 over 4. Now we have the same triangle. We are going to go ahead and make that. We had that legs were 3, 4, and the hypotenuse was equal to 5. Now, with the blue angle, we're going to go ahead and label, and we're going to go ahead and call that beta. But even though the hypotenuse stays the same, the opposite and adjacent side switch, and that's because we are in reference to this blue angle here. So right next to the blue angle, that side that is touching it, that is your adjacent side. And then the other side across from that, that is your opposite side. Now, before I go through and find the sine, cosine, and tangent of these, which is just going through and putting in the ratios of the opposite, adjacent, or hypotenuse sides, I want to talk a little bit about the relationship between theta and beta. This is a 90-degree angle triangle, so I know this is a triangle. So what do I know about this? I know that theta plus beta plus 90 degrees has to equal up to 180. I also know that then theta plus angle beta has to equal 90 degrees. And this brings up an important relationship. So the important thing to realize with this is this says that beta is equal to the same thing as 90 minus theta. So in essence, what I'm saying is this angle over here, the blue one, that's not just beta. That's also the same thing as saying 90 minus theta. That angle is the same. And this brings up an important identity. And the identity is just that the sine of theta is equal to the cosine of 90 minus theta. But remember that 90 minus theta, this is actually beta. Those two pieces are equal to each other. Those two are just the same. I just substituted them in. So let's go ahead and take a look at this. So, and let me show you how it works. So if I talk about the sine of theta, and again, remember theta is my red angle up here. So the sine is the opposite, which is 4, over the hypotenuse, which is still 5, is the same thing as the cosine of beta. And beta, I use the adjacent side. Again, this is my blue angle, so this is why I'm going to use the labeling that I have in this triangle. So this one is also 4 over 5. And beta is 90 minus theta. So to use this identity, one of the things that you can do with this is if I tell you to find a cofunction, and I tell you that the sine of 72 degrees, well, I know that the sine of 72 is equal to the same value as the cosine of 90 degrees minus 72 degrees, or the cosine of 18 degrees. You can do the same thing with radians. So if I say that I have the cosine of pi over 3, that is going to equal the sine. Now 90 degrees in radians is pi over 2, so then it becomes pi over 2 minus pi over 3. You do need to find a common denominator with that, so I multiply the top and bottom of one fraction by 3 over 3. This fraction gets multiplied by 2 over 2. And I am now left with the cosine of pi over 3 has the same value as the sine of 3 pi over 6 minus 2 pi over 6, or the sine of pi over 6.